Hello, and welcome back to the official podcast of the 2024 International Fuel Ethanol Workshop and Expo, or FEW. My name is Danielle Piekarski, and I am your host. Joining us today is Matt Bilski, lead chemist at Ecolab. Matt will be presenting at FEW in Track 1 on a panel titled The Economic Argument for a Commitment to Robust Plant Cleaning Regimes. This panel will take place at 1 p.m. on Monday, June 10th, and Matt's presentation will focus specifically on the importance and how-tos of reuse CIP. Matt, thank you for joining us today, and welcome to the podcast.
Thanks. I'm happy to be here.
So let's kick things off by having you just share a little bit about your company, Ecolab.
Sure, Danielle. So Ecolab is a global sustainability leader, and we offer water, hygiene, and infection prevention solutions and services that protect people and the resources vital to life. We build on more than a century of innovation, and we deliver comprehensive science-based solutions, data-driven insights, and world-class service to advance food safety, maintain clean and safe environments, optimize water and energy use, and improve operational efficiencies for customers around the world.
And as lead chemist at Ecolab, what are some of your responsibilities, Matt?
So as a lead chemist, I work primarily focusing on the food and beverage business within North America. And one of my areas of focus is developing our innovation strategy and implementation of product offerings in our grains, oils, and biofuel space. One big segment of that is the bioethanol industry.
Great. Well, let's get into your presentation. Can you explain to our listeners a bit about what CIP is and what is the most important part of the CIP process to ensure that it is successful?
Sure. So CIP, in case that's an acronym that someone has not heard before, it simply refers to clean in place. And it's the concept of running water and chemistry through pipes to clean them in a system rather than having to take them apart prior to cleaning. And it's a way to do it faster, more efficiently, especially when you start to think about large scale plants for production, whether it's food or beverages or bioethanol, the amount of units, fermentation tanks, lines of piping that would need to be taken apart to be cleaned. It's impractical and not possible to do. So that's really the basics of a CIP. The simple answer to how to make sure it's successful is to execute your actual wash process effectively. But at Ecolab, we like to break that down and look at it as really four pieces of a pie. And those four pieces are time, so how long you actually execute your wash process, temperature, what is the actual temperature of your wash solution that you're using to clean, concentration, and that refers to the chemistry that you use. Are you using the right chemistry for the soil that's trying to be cleaned from that equipment? And is it at the right concentration mixed with water to effectively remove the soil? And the fourth one being mechanical action. So that would be the actual force generated by the cleaning solution, whether that's a spray device in the event that you're cleaning a tank, or the speed at which the water and cleaning solution is running through a pipe to generate mechanical action. We look at them as four pieces of a pie because depending on the required process, the relative size of those pieces can change. For example, say that you want to clean a piece of equipment faster. By using a higher concentration of a specialized chemistry and increasing the temperature of that wash solution, the time to clean may be able to be dramatically reduced. Say, execute that clean in 30 minutes as opposed to an hour. But there certainly is a trade-off there, and you're using more chemistry and you're using more energy to clean at a higher temperature. Conversely, if you wanted to minimize energy use, and that was really important for a facility, washing at, say, a lower temperature might require more time and perhaps a different chemistry to be able to clean. There are many different ways that those four factors can be adjusted. Again, time, temperature, concentration, and mechanical action, depending on what is of primary importance to that facility or that location, in order to make sure that they're achieving a good CIP process and meet whatever other goals they may have in terms of energy or spend and something like that.
Okay, so I would like to talk a little bit more about the chemicals being used. Is there any advantage to cleaning with those more expensive, specialized chemicals versus commodity caustic?
I mean, of course, I'm going to say yes to this question. But seriously, like the real answer is it really depends on what you're trying to achieve and what is the piece of equipment that you're trying to clean. Something like commodity caustic is going to clean general carbohydrate-based soils pretty well if it's given the proper time, temperature, and concentration. You know, going back to again those factors I talked to, but it's not always that simple. Soils are rarely one individual type. They're often blended, and it makes it more complex. In the case of think about bioethanol, caustic also brings sodium into the system, which over time is known to have a negative impact on the yeast and their ability to generate ethanol, and if it gets too concentrated. So that's an argument for looking at alternatives in the bioethanol space. And also one of the reasons why regularly dumping and making a fresh CIP solution is a good idea so that you don't end up with these really high levels of sodium for your CIP system. Formulated caustic products also bring additives in that help clean, say, at a lower temperature, or you can use a lower concentration while getting that effective clean. And they also may target a specific type of soil. Like, for example, is there mineral scale that's building up on a unit that needs to be cleaned? How about beer stone? Formulated chemistries are able to effectively go after those or even prevent them from forming in the first place. So options there of why having those more specialized design chemistries can help with that stuff. Beer stone, one final call out on beer stone, it's a common place to act as a harborage point for microorganisms, which certainly can create a whole other set of problems when you think about firms stalling, from an infection rather than being able to run to completion if, say, there's lactic acid bacteria building up inside that firm.
All right. One last question for you here, Matt. What would be the number one thing that you would recommend to all the producers with regards to their cleaning process?
If it's okay, I'm going to cheat a little and I'll give you two answers.
That is fine.
Sure. So the first one, the biggest thing I would say is something that I heard over and over again when I used to work primarily in the brewing industry, and I heard it from brewers all the time. Effectively cleaning our breweries is the most critical part of our job. I really, truly believe that that also completely applies in this bioethanol space as well. These massive facilities are producing an extremely high volume of ethanol at a really high rate of speed. When you think about it, it's crazy how fast bioethanol facility is generating product. We can get lost in that speed, but working with a properly cleaned system will really go a long way to help with their overall production. Wouldn't it be an amazing thing to just know, yes, my system is clean? And one thing we've heard, most customers, most bioethanol facilities, they are using antibiotics to control bacteria and sometimes even as a security blanket. Wouldn't it be great if you didn't have to do that and you just knew you had a clean system? So that I would say is the first one. And then the second one, regardless of who your chemical vendor is, having a chemical vendor for cleaning and sanitizing that understands the process, the soils, the solutions, and who will work with you to solve the problems to benefit your operation. One of the great things that I find about working at Ecolab, and I really enjoy when I work with customers, is our scope. Because we're such a large and complex company that covers a variety of segments, it gives someone like me in our R&D group and our technical experts in the field, not only our breadth of experience, but experience from other segments, other areas to draw from. We learn from that and we can work together. More often than you would think, we end up finding a solution to a problem for one segment of our business from a seemingly unrelated segment. I'll make an example up, but say our laundry business brings a solution or has a solution to a problem that we can apply into our bioethanol business. Those are the types of things that we see. And with our breadth of scope, we're able to work together and bring to our customers. So really, it's available knowledge and resources that your vendor can bring to help you solve problems is the second thing.
Awesome. Well, thank you, Matt, for coming on the podcast today. If our listeners would like to hear more from Matt, his panel, The Economic Argument for a Commitment to Robust Plant Cleaning Regimes, will take place at 1 p.m. Monday, June 10th. Matt, thanks again for joining us today, and we will see you at FEW in just a few weeks.
Thank you, Danielle. I'm looking forward to it.
Yes, so are we. And thank you to our listeners and FEW attendees. If you are interested in attending or would like to learn more about the conference, visit few.bbiconferences.com for more information. Thank you for listening, and we will talk to you more on the next International Fuel Ethanol Workshop podcast. Until then.